Well, hello everybody, welcome back to the channel. Let's try another video. How about this? A little different. Let me show you what I got. A friend of mine gave me this little dude. The Bible says, ask and you shall receive. But it's an RCA Solid State WV510A. Apparently it has a battery in it. I have no clue if it works. It's a little dusty. RCA badge, it's not a Viz. So, got a BNC connector on it. I don't know how good these things are compared to others, but let's have a look at it. The front of the meter's in good shape. It's missing the little chrome insert on the function switch, like this one here is on the range switch. It's got a little surface rust here and there, just like that right there. That can be fixed, no big deal, I don't think. CS does it does DC current. How about that? AC, RMS, or peak to peak, DC volts minus, DC volts plus, R ohms, and then battery test A and B. Does that battery testing mean internal batteries? Which it probably does. It has to be. So let's turn it around, look at the back. Power cord. Looks okay. Got a little corrosion right there. Well, let's have a look at it. RCA Master VoltOhmnist model WV510A. Serial number 234540, looks like. So, not sure what the vintage is of this, but let's let me get a Phillips head screwdriver and I'll pull the cover off this and let's investigate inside, see what's in there, shall we? Alright, we have the back off and kind of what I suspected. Dun dun dun. Battery A and battery B has left the building. A little bit of corrosion on the chassis right here. I'm looking at the circuit board. A lot of stuff in there. Ooh, look at there. See a 9-volt, looks like a 9-volt connector. Another 9-volt. And a third 9-volt. And a fourth 9-volt. I guess that's what that is. And then we got a Hercules. For industry, not designed for retail trade. Hercules trademark battery. Soldered in leads. So, takes a bucket load of these 9 volts. I assume that's 9 volts. I don't know. Never had one of these before. Circuit board looks okay. I don't see anything. It looks like, well, there goes the alignment. Look at there. A little alignment punch hole. These are okay. These two are intact. That one there and that one there. I don't see any corrosion right off the bat. I say let's plug the AC cord in and turn the thing on and see what happens. What do you think? Do this with one hand. One-handed, y'all. Could have done this while I had to. How about I just do it the right way? I'll bring you right back. Okay, hang on. And get a sip of coffee here. I have the ohmmeter or the voltmeter plugged into my Syncor variable isolated power supply. So power it up. See what happens. It'll work or it won't. We have turned it on. We have it in the 15 volts position, positive DC volts. Let's see if it'll zero. Well, that worked. Let's see negative volts. That worked. All right. That works. Ohms. Uh-oh, did y'all see that? Oh, Lord. See what it did? See how that meter's responding? Y'all saw it. I saw it too. Plug this back in. See it hang up? Oh, honest to God, I hate it when the meter movements do that. Saw that, didn't you? Maybe there's something in there, trash or something. God, the last one we checked, remember that guy? That's so annoying. I doubt this meter movement is, see it? I doubt this meter movement is the same. Let's find a precision resistors right here. Let's see if this thing even works right. And we'll check the DC and AC voltages. So let's get a, let's see, what is this right here? It's a 9.9 meg. $500K. I believe that's 100,000 ohms right there. I think this is 1,000 ohms. 1,002. So let's see. Well, it ain't 1,000 ohms. Oh, that's 102C. That's its temperature coefficient. So it's a 0.1. Yay. Don't have any precision resistors around here. Well, here's a 10 ohm. That's all I got. Dadgummit. I'll find something that works, I promise. There's R times 10, that's 50. Go down to the... R times 1 is still showing 0.5. Showing 500K. I mean 50 ohm. I don't know. Why can't I ever get anything that works? What I want to know. Yes, 500K. Exactly. So this thing ain't very accurate, is it? So let's come back up here to R times 10K. R times 10K, and this is a 500,000 ohm resistor. Shouldn't that been about on the 50 mark right here? Yep, problem there, I guess. Problem with the meter movement, sticking right there about the 30. The ohms range is not working right. So let's see what it does on a DC. Let's give it about 20 volts. 15 volt scale. 15 volt scale. I'm sorry, 50 volt scale. 50 volt scale. It's showing about 20, a little less than 20. Drop it down about 8 volts. About 7.5. Alright, drop it down to 5 volts. Run it about 4 volts on that. So that's about, see it sticking? See how that needle just stops? So a lot of times that's indicative of a static charge on the meter face. But a lot of times that's indicative of a meter movement that ain't quite working right. So we're down to 1.5 volts. So AC volts. Of course, I don't think I had this thing calibrated right. What do you think on AC volts? Let's hook it up to a signal generator and see what happens. Hang on a second. Okay. What I'm doing is I've set my audio generator for 1.5 volts out. 1.5 volts. That's about as much as I can squeeze out of that thing. Anyway, 1.5 volts according to this fluke. So let's see what we got here. Let's make sure this thing is zeroed. Seems to be. Plug it back in. We're on AC RMS or peak to peak. We're on the 5 volt scale. So the 5 volt scale, we're just shy of 1.5 volts. So, it all seems to be about the same amount, DC or AC volts. So, I think that's probably just maybe an alignment because they all do the same amount. So it probably just needs a good alignment as far as that goes. But the biggest problem that I see with this is that sticking meter movement. You see it, how it did? Put it back on DC volts. It stick. See, hang it. Get that little bitty spot in it right there. See it? Always stops about a little past the 11 mark on the 15 volt scale. This could be something in there, dirt, trash, or something. So, oh my Lord, no telling how hard that is to get out. Let me see what I can figure out. Bring you back. Just for curiosity's sake, I went ahead and clipped the battery out, the 1.5 volt battery. So let's see if it's any good. Tell you what, the things they made back in the day. Let me rephrase that. The batteries that they make today can't hold a candle to what was made back then. Got it set on 1.5 volt, 160 milliamps. See if I can do this with one hand and y'all can see me in the frame. Hard to do this with one hand. Alright, I just broke down and got the tripod out. Alright, I got the meter. Got my battery tester ready to go here. If I ever get these leads in my hand. Alright, well, it's dead as a doorknob then. Dead as a doorknob. Dead, dead, dead. Just as a sanity check, we'll get a good known good battery. Checked very well, as you can see. Not this one. This one, it's dead, Jim. Not an ounce of power left in it. That sucks. Alrighty, what we needed to see. Hey, look at here. Still has the Radio Shack sticker. See it? $9.95. Alright, well, let me get you situated right here. Widen you out a little bit. So we got the meter fixing to be unplugged. So I'm gonna need to be able to get into meter movement. Now you can unsnap it here, here, and here. Here, here, and here. But I don't remember if this will come out. I want to break it. Don't think it's going to come out. If I take this screw, this nut off right here, there's a nut holding it on. There's a nut there and a nut there. And then two here, one here and one here, to allow the meter to come forward. I don't want to pull it out of its case. Meter leads are these two, red and black wire right here. Pull this piece of plastic out of the way. Yeah, the meter leads are right here. I think if I got the meter out, took these four nuts off, and I got to take, that just pulls out, so that's good. I'm going to take these four nuts off and see if I can get the meter out enough to pull the front bezel off of it, or the front cover off of it. See if we can destroy another meter like we did the other day, right? You ain't lived until you broke a perfectly, well, until it broke a meter that, like we did on that Heathkit transistor tester. Of course, it was already broke. I just tried to make it better and failed miserably. Story of my life. Hang on just a second here. Plug the charger back into this camera. There. Get you a little bit better in frame. Sometimes I'm going to drop stuff in this meter. This ain't on my A game today. Been at work all day. We unloaded an 8,000 pound roll of 5-inch flexible heliacs for a job project we're on. See if we can get it out. Should be able to. There we go. Now let's see if we can just get it off. Remember, kids, black to minus and red to positive. There's the phone. Going crazy. Might pester me. See this mess right here? I get this mess all the time. I don't know where it comes from. It's just political bull crap people send to me, like I didn't register for this. Anyway, let's fix this stupid meter. What I need is a little voltage. I need a little bias. So let me get, yeah, this 500K of resistor would be just fine. Let me get a clip lead and a power lead. Somewhere in this rack of stuff, alright, here we go. I just want to be able to swing the meter so I can test the movement on it. I think this is a 500K resistor. Before I apply full power to that, let's turn that voltage all the way down. So now I'm just going to take my power supply, got it on 0 right now. Supposed to be a 500K resistor. Let's see what happens when I adjust the voltage. Here we go. That's 24 volts. Yeah, 500K. That's too much resistance. Too much resistance. Let's go down to 100K. What am I doing? What am I doing? Nobody knows. Y'all don't know, I dang sure don't know. Let's get out the box here. Lord have mercy. It takes me forever to learn something. My resistance capacitance substitution box. Duh. Alright, we want a high resistance. Our high, we're going to start at 330K. Actually, let's just start at 470K. Now, get rid of that. So, it'll be the first time I've actually used this thing since I had it. Alright, so we're at 20 volts on the DC power supply. So let's do 470K, so let's drop it down to 330K, 220. Here we go. I'm at 150K. Here's 100K right there. Now I can get full deflection. Look at there. See it hang? See it hang right there? So if we recreated the symptom out of the voltmeter, which is no big duh. Alright, part that I just extremely love. So a little bit of tape right here over this. Make sure I got some canned air for this next step. Hey, I'm not telling you guys to do what I'm about to do, but the thing's not right anyway. So I'm going to pull the face off this meter. Don't know how brittle it is. I don't know if it's glued in or what. Probably is, knowing my luck. Take your time with this stuff. Got a lot of debris on it. Oh my gosh, there it goes again. Okay, here we go. Y'all still in frame, camera still rolling. Y'all about to see me break another meter. Was a piece of trash inside. It could have fell off. What I'm basically going to do is I'm going to short out the back of the terminal with a clip lead, and then I'm going to take compressed air. Oh my lord. Here we go. Gave it a good blast of air inside. And what I did was clip lead across the meter terminals. It created the brake. What to call it? Kind of like a dynamic brake in a train engine. But it just it's a magnet versus the coil. When you short the coil, any movement counter reacts itself, or counteracts itself. It makes it stop. All right, so let's see if it made any difference. And if I would hook this thing up properly, I gotta put it down, prop it up on something. Now, let's see if it done any good at all. Seem to be stopping, but then again the day is young. Let's put it in its normal operating position. Alright, let's try it again. Hang on. See the wind current flowing around here? That meter swiveling all over the place. Seems to be working at the moment, so let's just power it off. Unhook it. Oh my word. I'm going to lay it over here out of the harm's range, and I'm going to put some more air on it. Don't tell them what this thing's been through, okay? Somehow or another they get dirt in them. Dirt can get in from the side here, dust, I don't know. But let's put the cover back on very carefully. Now, let's test it one more time before we put it back in the meter. Okay. Plus to plus, minus to minus. Here we go. Turn power supply on. It works so far. So let's put it back in the meter, put the meter back together and all that good stuff. The 20 microfarad 50 volt electrolytic stuck in there. Might be something we need to think about. Now, do y'all remember if that was up or down? I think that was pointing up, wasn't it? I think it was. Where are the nuts and screws out of the meter? What did I do with the nuts off the meter? There we go. Hopefully this will work. We ain't got another cotton picking meter with a bad movement. I'm getting really tired of that mess. I look on eBay and how much that little transistor FET tester was that on eBay that I got. Things, people wanting a lot of money for them. Not that I want to sell mine, mind you, but I'd like to buy a used one just so I could get the meter movement. But I ain't buying it at the price you people, crazy people, want for these things. Like $275, $300, $400. Like, for real, for a heat kit? I'm telling you, man, some of these prices on eBay nowadays are ridiculous. It wasn't, but about 8-10 years ago, you could go in there and look for an RCA, I think it's a WV510 or whatever it is, the little 3-inch RCA oscilloscope. There's a million of them you could be found. Yeah, you can get one for $10 plus a little bit of shipping. Let me see you do that now. $200, $300. Thinking old RCA general purpose radio TV oscilloscope. I get so dismayed by prices nowadays. When I had an eBay sale here a while back, I didn't get premium prices for the stuff I sold. I lost my shirt on this eBay sales. Even when I added to my shipping, I still lost money on the shipping. I mean, inflation is just a joke nowadays. See, I mean, just to ship a little old Class 1 package, I think $8 or $9. Oh, that's ridiculous. Alright, let's see what we got here. Meter movement has been installed. Let's hook up the power supply. Alright, can y'all still in frame, hopefully? Alright, give me a second to get the power supply, everything hooked back up like we had it. Almost there. Let's go ahead and power it up, see if it even works. It actually doesn't. I don't know. Everything's twisted, wrapped around everything. Lord have mercy. Meter is dead. Why is my meter dead? Something touched something it shouldn't have touched and blew out every transistor in it? Did we lose the power supply? Is it the 5-volt battery's got to be in there for this stupid thing to work? I do not know. Power cord. Is the power cord bad? What the devil changed? Whoop, there's our ohms. Okay, must be the power cord. Alright, well, alright, we got a reading. Alright, let's see what it does. Let's see, DC volts. Look it up. See the meter? Good. Alright, let's bring it up. Put it on 15-volt scale. So far, so good. I've been fooled by these stupid things before, though. Because this is about where it would stop right there around, oh, let's see, around the, close to the 30 on the ohm scale, or the 3.5, 6, the 3.7 volt mark. Or the 4-volt RMS mark, whatever you want to call it. It don't matter to me, just whatever floats your boat. So far, so good. I want to see just how stable this thing is. as far as input voltage. Just right now I've got it just set here. We'll just say, let's set it on the 3 volt DC mark. I'm going to vary the line voltage of the down to 100 volts. It's still showing 3 volts. Bring it up to about 125. It's still showing 3 volts. So it is something in there regulating. So I got it back on the calibrate of 117 volts right there. So it does have an internal regulator. That way when the line voltage fluctuates on the input of the meter, that it don't go all wacky. So maybe we gotta actually fix this meter movement. I don't know how old these things are, but I'm about to see if I can find the manual on this and look around on it for a date code or something like that. I should have done that when I had a meter out. But I think the meter's good. It's working right now, so let me see if I can find a schematic on this. I'm going to let this thing warm up. I'm going to find me some batteries for it. Go ahead and put the batteries in. I don't think it needs batteries. I don't know. The 9 volts were bypassed with these little sleeves. I guess that's 9 volts. These are all bypassed with sleeves. Only thing that was in there was the 1.5 volt. So maybe I'll just put the 1.5 volt back in with a new battery and just play dumb, which it ain't hard for me. So let me leave the research, and I'm going to just let this thing run, and so I can let it warm up. You know about calibrating stuff. You got to let it warm up for an hour, 4 hours, or whatever, depending on what it is and the manufacturer's suggestions and all this horse hockey. So, all right, I'll be back shortly. Hopefully, maybe. Okay. I haven't looked up the schematic yet, or the book, but I did put a battery in, a fresh battery in, a 1.5 volt D cell in here, and I'm retrying the ohms function of this thing. So, if this does like any other VTVM, the lead's open, you set your needle for the infinity mark, whatever they call it nowadays, the hourglass looking thing. Then you ground it, set it for 0 over here, and you go back and forth till they are infinite and 0, infinite 0. Once you got that, you're set. So now hook it back into my RC substitutor, my resistance capacitance box. And Viz, by the way. So I'm at 220 ohms, the low side, and it's reading 220. 330, I'm reading 330. 470, I'm reading about 680, it's about 7,000 ohms. It's just a tick over 1,000. 1,500 ohms is pretty close. Let's see, 2,200, we're getting there, not bad. 3,300 ohms. Let's see, 4,700 ohms, about 50. I don't know what the tolerance is of these resistors, but it is tracking pretty well. So now let's go to 100,000 ohms. So I'm at 100 right there. It's just a little bit over 1. Of course, we haven't zeroed the meter, but 150K. Let's see, 220, 330. This seems to be tracking pretty good. It's like I say, I don't know the accuracy of this thing. So that's good. The 1.5 volt battery, I guess, might have fixed that. So, what next? What next? Next is I'm going to look up the schematic for this thing, or the user manual, and see what all it's going to take to adjust this bad boy. Maybe more than I want to do today in this video, because I only have about 40 minutes left before my wife comes home. Let's go back to this a minute. I'm showing 3.3 meg. Let me check the calibration on this again. Okay, that's 0. Yeah, that's pretty spot on. It didn't change any. Alright, hook this back up. So it's 35, about 3,800 ohms. So let's see what my fluke says about it. Zoom you in a little bit. So now I'm going to take this meter here. Actually, I'm going to just do it this way. Let's measure the RC box, and let's just see if it's really accurate or not. I don't know. We'll just put this on 20 meg. Let's see, K ohms. Oh, right now 3,300 ohms is measuring 33.69 K or 37. Let's do the 1 meg here. 1 meg is showing 1 meg is showing 1.023. And let's go back. Hey, let's compare it to yet another meter. Compare it to this guy right here, wherever it went. Widen you out. Compare it to this here Fluke 77, the venerable Fluke 77. Alright, we're just going to plug this into there. This is showing 1.021, and this one's showing 1.020. So I'm going to trust that. So let's see what the meter, the WV510 says again. Okay, we're going to check calibration again. It's calibrated. I hadn't looked in the manual yet because I hadn't looked it up. So 1 meg showing just a little over 1 meg. So it's not that far off. But I know the DC volts. I know the DC volts and the AC volts are probably going to be calibrated. But let me look up a manual and see what it's going to take and decide if I want to do this today or not. I might at least try DC calibration and see if it tracks. So I'll bring you back when I find information, if I can find information. Sometimes you can on some of this stuff. So I'll bring you back. Alright, I did find a manual on the Bama webpage. Boat Anchor Manual Archives. Just if you want to find that, just anyway, the first thing we have to do is the internal balance adjustment. It says check the mechanical zero position of the pointer. If necessary, reset mechanical zero as described on page 22. Mechanical zero adjustment. The meter pointer should rest at the left hand zero mark when the function switch is turned to the off position. So we'll look, and it does not. So we get to adjust it. Woohoo! Let's get the adjusticator. Pull that little button off right there. It is not quite on zero, so very delicately think. These things are always a pain in the butt. Honest to goodness, hate these things sometimes. Okay, mechanical zeros mechanically is adjusted. So I'm going to turn it back on. Now the next thing we want to do, alright, we got the mechanical adjustment done. Step 2 of the internal balance adjustment. Temporary connect jumper wire between Q3 and Q4 base. So here's Q3 right here. Q3 and Q4, they want a jumper between this base and this base, and here is a capacitor called C6, which is a 0.005. If we look on the back of this guy, there's a capacitor, and it just happens to be the capacitor we're looking for. But I did notice while I was in here, there's some lead right here and another lead right there sticking out. Not sure what that's all about. But according to the schematic, this capacitor should be shorted out. We're fixing to probably blow it up. Short that capacitor like the book says. Alright. Looking back at the meter. So it ain't left no smoke yet. Alright, you've got the jumper connected between Q3 and 4 base. Turn function switch to minus DC. And the range switch to 0.5 volt. So we bring that joker all the way down. And let's turn the stupid thing on, Sam Hunter. Adjust the zero control to bring meter pointer exactly to 0. Alright, there's exactly to 0. Check for correct 0 setting by switching the function switch to plus DC. It moved just a tad. Alright, I'm going to remove jumper wire. Jumper wire is removed. Alright, so now we've done that. Step 4, set the function switch to the plus DC, which it is. Let's see, adjust R10. Well, of course, the range switch is going to have to be cleaned. All right, let me clean the stupid switches. Guess I should have done that first. Anyway, I used my favorite cleaner, the QD contact cleaner made by CRC. It does a good job. It's fast drying and it don't harm plastic. What more can I say? So let's do this again, because I think I missed a step. So we're going to put this on minus volts. Put it across my jumper across Q3 and Q4, which is C6. I'm going to adjust the needle for exactly 0, which we have right there. And it tells us the half ohm scale, and 0 control to bring meter pointer exactly to 0. Check for correct meter, correct 0 setting by switching function switch. Yeah, it's weird. It said minus turn function switch to minus DC volts at range 0.5, adjust 0 control, so that's what we did. Alright, so then adjust 0 control to bring meter pointer exactly to 0. Check for correct 0 setting by switching function switch from plus DC volts to DC volt to minus. So I'm thinking they're backwards. Anyway, it does shift just a little bit. So I've set the function switch to the plus DC position. Alright, I'm going to remove the jumper. That's what it says. Make no sense to me, but alright, whatever. Alright. I've removed jumper, set the function switch to plus DC, adjust R10, the internal balance control. I mean, absolutely makes no freaking sense. Do it again. It don't make no sense. It tells you to go from one to the other, then back to the other, back to the other one. It's just like, it don't make no sense. How did it jump? Okay, that is done. Shifted just ever so slightly. I don't know. I've done exactly what you said. It says turn the function switch to minus DC volts, range switch to 0.5 volts, adjust to 0 control for 0, which I've done. Alright, check for correct 0 setting by switching the function switch from plus DC volts to minus volts. Well, it never told us to go from DC volt back to DC volts. It just said put it on minus DC. So I guess, let's do this again. Let's put it on plus DC volts, because I think this is backwards. I think this is backwards. I think it's going to do the same thing. I think they got their wording backwards on this. Alright, I've done it. I've set it. I turned the function switch to plus DC volts this time. Range switch to 0.5. Adjusted to 0 control while it was in plus DC volt to exactly 0. Now I'm going to switch the function switch from plus DC volts to minus. That makes more sense. And it shifted just ever so slightly. So they want you to remove the jumper, which I have, and move this back to plus DC volts. Alright, so let's see, put it back on the DC plus, adjust R10, the internal balance control, to bring the meter pointer to 0. Okay. Where is that control? We're looking for R10, internal balance. No idea. R10, that right there. So this is the component side. We need full side, and there's R10. So and when you know it, that's the one that's been adjusted. Who'd have thunk, right? Here we go. Oh yeah, that pot is really dirty. I had a feeling that was going to happen. That's what you get with this old stuff, ladies and gentlemen. I'm just going to spray it. Yes, with it live, ladies and gentlemen. Don't hurt my feelings at all. There. You just keep turning back and forth. I ain't putting that stupid jumper in there. We may have to wind up changing this control because it is super flaky. Yeah. Won't stay set. See how flaky it is right there? Really flaky. Yeah, it's one of those CTCs. And I don't think I even got any cleaner on it. Let me see. Move this battery out of the way so I can see what I'm doing. Yeah, it's that one right there. Actually, it's not. I missed it. Sorry. Yeah, then. Let's try that. That might work better since I might have got... I don't think I got any on the contact surface. Super touchy. Super touchy, but it's better than it was. I'm just flipping it back and forth. Till I get no change. That control is not stable. So it's getting close to the end of this little video. This thing is super unstable. It doesn't stay where I want it. Seems to be copacetic right now. I'm going to let it go. I'm going to let it run at that. As you can see, moving it from minus to positive volts doesn't move. We're gonna move. We're gonna move on. Alright, so we got that done. Input impedance adjustment set. Function switch to R ohms. Okay. And the range switch to R times 1. Alright, it's just ohms control for exactly full scale reading, which we have. Set range switch to R times 1 meg. Alright, now what? If meter drops below 1,000 on the ohm scale, simultaneously adjust. Well, it didn't do that. Make sure it's working, which it is. Now I say that's fine. So the input impedance adjustment did not need adjustment. So here we go to the DC voltage calibration. Woo! Turn the function switch to plus DC, which we have got. Range switch to 0.5 volts DC. So all the way back down here. Alright, adjust to 0 again to bring it exactly down to 0. Turn the range switch Turn the range switch to 0.5 DC at plus 0.5 volts from a precision voltage source to the probe. Well, I don't have a precision source, but I got a 0.2 volt oh yeah, this stupid thing really precision. We're gonna do the best we can with what we got, folks. That's what we're gonna do. Yes, sir, Bob. That's what we are going to do. Use what we have. Do not have a precision source. I never have. I'd like to buy one, but they're kind of expensive. These little kits these people talk about. Oh, we got that backwards. We're going to put it up against the fluke. We're going to. Fluke's pretty accurate. I mean, if I'm going to measure DC voltage in the shop, I'm going to measure it to this anyway. So I don't guess it makes much difference, does it? So I'm going to do that. Alright, we'll measure DC volts. I'm going to measure 2. So we're at 0.459. So I'm going to bring that up a little bit. There's 0.5 at the moment. Notice I say at the moment. So it's set up here to measure. Just on DC volts. I knew that was coming, didn't y'all? Stay up there. Nuisance. Alright, not quite 0.5 volts. Fluke says at 0.495. We're at 0.505 right now. Not quite 5 there. So let's find the DC voltage. Turn the range switch, apply 0.5 volts from a precision source. Second page of this mess. Just R2C to bring the meter point at full scale mark. So let's find 2C. (2C) is the bottom control here, and it just happens to say 0.5 volt. There we go. That says 0.501, that says 0.5. So I'm good there. Alright, so let's function switch to minus DC volts. Reverse the leads. It's almost there. Alright, we're at -5 on meter, and this one needs to be brought up just a little bit. So we got the minus 0.5 adjustment to do. Alright, that one's done. Alright, so connect the output of a precision 1.5 volt DC voltage. Okay. See where this is going. Go back to positive. Short this out. Zero it. It's almost zero. go to 1.5 volts. The tolerance of this, or accuracy of this, is plus or minus 3%, by the way. Get my, doing the best I can here, guys. I mean, it is an analog meter, and it is 3% accuracy. So, all right, so we're at 1.5 volts, and make sure it's zeroed. There you go. Meter zeroed. Good. So, let this back up. Watch it fall off. Almost there. So 1.5 volt ground line R2A DC cal to bring the meter point exactly to 15 on the 0 to 15. So we'll need R2A. So that's going to be 15. I guess it's going to be DC. I knew it. Thinky little rump back up there. Give me the red butt. Here we go. And another slightly flaky control. Anyway, 1.501 on my fluke. It's showing full scale at 15 on this meter after it's been zeroed. So we have done the DC voltage calibration. So next thing we're going to do is the DC current. And that shouldn't be too hard. We got to have a constant current source. So I'm basically just going to do something. So what's it say here? Set the function switch to DC current. Which is that one, and then I'm going to put my test leads here. Come on now, get out of the way. I assume that's correct. Alright, so DC current, set to DC current, set the range switch to 0.5 volts milliamps, DC current, 0.5 volts. 0.5 volts DC. Doesn't say /MA though. Was it 5 volts or 0.5? 0.5 volts /MA. I don't know. Your guess is good as mine. So now I'm going to set I don't know if I got a meter to measure amps. I'm not going to worry about that. I ain't never going to measure AC, current with this meter anyway. Yes, I skipped a step. Function switch to AC, the range switch to 50 volts, probe to AC ohms, adjust zero control. So AC volts. And I think it wants 50 volts, and we're going to zero this. First off, we're going to set that to zero, set the function. Probe switch to AC ohms, adjust zero control, adjust the ground lead and probe to an AC voltage source of 50 volts RMS. Well, that's all we need to do is adjust this. So we're going to plug the meter into the outlet. then we're going to use this guy as our voltage, AC voltage source. Yeah, that makes a lot of sense, don't it? See how kind of fun I have around here? So let's undo that. The method to my madness, I promise. Alright. Once again, we're going to use this guy here. I'm going to set this up for measure 50 volts AC. And I'm just going to use my AC power supply here. And set it for 50 volts. And at the same time, I'm going to set this guy I've got a problem with the thinking plug, and I think it's right here. Jumper out of the way. Something, AC power plug or something's messed up on this somewhere. Could be all that corrosion on the end of this plug right here. It looks like funky donkey. Mighty green, that's probably what we were trying to get through a while ago. We'll have to put this in the there it goes. That's what it was. Yeah, there goes the accuracy. Anyway, bring this up to 50 volts. AC calibration, AC range switch to 50. So I'm in AC 50 volts. And meter zeroed, ground leading probe to AC voltage source 50 volts RMS. I'm going to adjust the power supply till it says 50 volts on the flute. Exactly 50 volts on the flute. There we go, close enough. Let's see if we get some sparks. No sparks. Get all this mess to hook up right. And 50 volts. A little shy of 50 volts on the meter. Alright, so we're supposed to adjust R2D. Wherever that is. AC right here, full scale. All right, 50 volts, full scale. All right, the meter is calibrated. Let's drop it down to, I tell you, let's bring it up to 100 volts. See how well it tracks. 100 volts. Yeah, it's a little over 100, but that is 100.3. That's pretty good, I guess. Still 3%. So 3% of 100 volts is what? 3? I didn't get that exactly 100. Oh. There you go. It's pretty close. Alright. Go back to DC volts. And we'll measure about 50 volts. Let's see if we can get into the AC plug. I think it's about as good as I'm going to get it. So it actually works. I can't believe it. Alright, so let's see. Let's get back to measuring here for a second. I'm about done with this thing, I'll tell you that right now. Been fun. Can't believe it actually works, personally. Alright, I want to measure. I can only get up to, I'm going to set it for 20 volts. That's just, it's only a 25 volt power supply. We'll set the flute to read 20 on the button. There we go, 20 volts right there. So now I'm going to take, we're on plus DC volts, we're on the 50 volt scale. I'm going to set this up. Meter is zeroed, so we're ready to do it. I'm just going to plug that in here, plug that in here, and let's see how bad off it is. It's reading just shy north of 20. And that's so aggravating. Why don't these things just stay set? $20 volts. Drop it down to 10 volts. I have exactly 10 volts, the best I can make it. Drop this down to 15 volts. And drop it down to 15 volts. Now it reads a little slightly less than 10 volts. So what I'm going to do, I'm going to split it in the middle. Slightly less than 10 volts. On that, and I'm going to bring it up a scale. If we bring it up there now, see that in there's reading high. So the multiplier resistors. Lord no, I hate fighting these things. It's good. It's 3% tolerance. Again, it's just a tiny bit above 1 volt. Another thing about these analog meters is if you ever look inside one, they've got little weights. If you look on them, they got these little ears pointing out the stator. In other words, you look in the aisle, you'll see these little spiral coils. Those are weights, and they adjust those weights to make that meter accurate track. It uses balance. It gets a certain slotted balances. It's really weird. But I had one VoltOhmnist one time that I had that I could set it, go to the higher range, it'd be just way off. Everything checked good. All the resistors and everything checked fine. There was nothing wrong electrically. Come to find out, did some Googling and reading, somebody else had that problem, and it was the weights on the inside the meter. One of them had fell off, and sure enough, I looked in here and it was missing that weight. So, being you saw, I had to take the meter movement apart on this meter. to blow out. It could there could be something missing there. Something has affected the accuracy of this meter movement. So I'm going to leave it there. It's accurate. It'll do the job. It'll tell you within voltage. If you're working on tube type, which is what these were designed to do, you're fine. I mean, now if you're working on something precision like a transistor bias circuit, I wouldn't use it. But to work on televisions and stuff like that, this is fine. So I think I'm done with this. Like I say, I'm not worried about the current. I'll never measure current on this thing. But I'm going to put it back in the case. I'm going to clean the corrosion off the case. I'm going to put it back together, clean it up real good, and figure out what I want to do with it. Well, that's that video. As helter-skelter as it probably sounds. And be done with it and pop another video out. So probably won't do anything else with it. I'll probably clean my bench up because it's 5:30 and my wife's going to be wanting to go out to eat. So that's that for tonight. I'll be busy tomorrow night, so I'm going to put the thing back together and get it all cleaned up, and we'll test it one more time and have a final to this video. How about that? And that may be Sunday evening sometimes. I don't know yet. Anyway, talk to you later. Bye. Okay, this is the final segment of this RCA WV510A. I took the case out to my back shop and did a little vinegar therapy on some of that corrosion from that battery, leaky battery, and cleaned it up real good, and it cleaned up real nice. Let me show you what we got. So this is the meter. Got it all calibrated. I didn't calibrate the milliamps. Call me lazy, but I didn't really have a good piece of test equipment to do that because I've never changed fuses in my meters because somebody blew them out. But anyway, the meter's still missing the little chrome, the little chrome insert here. Oh well, gotta have a story, right? Anyway, it all functions. It's accurate within 3%. Almost function works now that we put the battery in it, but this is a very clean meter. Very clean meter. It cleaned up rather nice. The probes they're good. All the leads are good. No burns. Usually you'll see these when they're in TV shops and stuff. You'll see burns on them right there and stuff. Everything's good. This could stand probably replacing, but I'm not worried about it right now. Just turn it around, let you look at the back. Here's the back. The case is extremely clean. It's come from a let's just say it come from a college. We'll just put it that way. A college classroom. So it didn't see all trucks, you know, in the middle of a service truck or on a bench where somebody smoked all the time. You know what I'm talking about. What these regular service meters are subject to. So this is where it comes from, a teaching establishment. All the resistors in it and everything is intact. Nothing's been overloaded or anything like that. So I'm not sure what I'm going to do with this. It's a good meter. I've got my B&K Precision, which is hard to say. I like that B&K. It's one like I had on the service bench years ago when I worked on televisions. But what to do with this guy, I don't know. Thought about selling it. I don't know what I'm going to do with it. Don't cost me nothing to hang on to it. I have to think about it. I've got meters that like this running. I've got VTVMs. I've got 1, 2, 3. I have 4 VTVMs. What am I going to do with them? Kind of like the radios that I work on. What do I do with them when I get them working? They sit. So I don't know what I'm going to do with this one. Anyway, it's a wrap on this one here. Successful repair. The meter did work. Whatever happened to it, as you can see, it swings freely now. It had to have been a foreign substance inside the meter movement. It gets that way over the years, and Lord knows, who knows, you know. But it's accurate within 3%. So with the best equipment that I had. So it's good. It's a wrap. Oh, and here's the old Hercules battery. Even in this age, it's got a little bit of corrosion on the top. But there ain't nothing like a Duracell. Duracell, that sucker would have been dead years ago. I don't know what I'm going to do with it. Might just put them up in the window and collect old batteries. I don't know. Anyway, hopefully this video don't act like I'm too stupid. But I get working on this stuff sometimes, and sometimes I run into something I didn't expect, and then I go off on this tangent, and I get carried away, and I get hyper and all this kind of stuff like this. And I've been saying, yeah, I need to do my videos different, and I never do. You know, it is what it is. You know, I get hyper, and then I had several things I worked on and thought it was going to be simple, and turns out it wasn't simple. And then I get carried away in the troubleshooting, and I forget all about filming or what the footage I have. I didn't want to show nobody, and I didn't feel like going through the hours of editing, so I just deleted it. There's a lot of content in my shop that I've deleted. Maybe I should have just made a compilation of all of it of Goose. That'd have been a good one, wouldn't it? Anyway, I thank you guys for watching. Please like and subscribe if you did find something mildly amusing about this, and because it would help my numbers. I do hope to one day have 1,000. I'm over the halfway point now, with thanks to all of you guys. But anyway, the meters, it's done deal. It works. I'm happy with it. Don't know what I'm going to do with it, so figure out what I'm going to do next time. So anyway, thank you guys for watching. Thank you for liking and subscribing. And I would hang around. I don't know what I'm going to work on next, but we'll find something different. I got to get back on that R2200. It's got an issue with the AM mod, and it's got a couple of issues that I'm trying to find the right test equipment to work on it with. It needs, I think it's an alignment thing, but I'm not sure. But you can't just, it's not like a single plane board you can work on. These things are multiple shielded. We'll get into it when I get into it. When I find a piece of equipment I'm looking for, we'll start working on it and see if we can figure out what makes it tick. Anyway, thanks for watching, guys. I tend to talk a lot sometimes, but we will see you later. Like and subscribe. And in comments or anything like that, that's nice, it's cool. If not, you know, they'll get automatically canned, and because I don't have time to listen to it. But anyway, talk to you guys later. God bless.